Today, I want to talk about a transformation. Our transformation is going to be the function 1 over x, and the density function that we're transforming is that of x. And its density function is 3x squared for x between 0 and 1. One of the first things we're going to be asked in a transformation, well, there'll be two parts. One is, what is the density function of the transform, which is y? The second part is, what are the range of values for which the density function of y applies? And let's start there. Those range of values correspond to the range of the transformation. The transformation being y equals 1 over x, and the domain is going to correspond to the domain of the density function f of x, i.e. x is between 0 and 1. So I'm going to graph the transform. The transform is y is equal to 1 over x. Here's x. 1 over x looks something like this. It goes to infinity as x goes to 0, and we're asked for a specific part of it. We're asked for the part between 0 and 1. So those are the x values. What are the y values? The y values are going to be 1, 1. Then this, it limits to infinity on the y-axis. So the range of y values, so the transform applies on y is bigger than 1, less than infinity. That's where our transformation density function y applies. Now, next, let's determine the density function of y. Okay. Now, I'm going to recall that the derivative of the CDF, the cumulative distribution function, the derivative of the CDF, i.e. g prime of y, that is equal to the density of y. I'm going to start by determining the CDF of y. So start with CDF of y, that's equal to g of y, and that by definition is the probability y is less than or equal to little y. Now, I can replace the random variable being this part, with its transformation. So the transformation is 1 over x is less than or equal to y. Now I know the density function of x, so the next thing I'm going to do is I'm going to solve for x since we know its density. Okay, so let's do that. And I'm going to give myself a little bit more room. So if I solve for x, this corresponds to 1 over y is less than or equal to x, where x is bigger than or equal to 1 over y. Okay, well, I know the density of x. I know how to calculate probabilities involving x. And here we're told that the density function is f of x equals 3x squared. Okay, so I integrate, and the integration limits are 1 over y to, well, infinity of f of x dx. Now, I don't truly have to integrate to infinity because the upper value of x for which this density is non-zero is 1. So I integrate from 1 over y to 1 of the density function. Let's just remind us what the density function is. It's 3x squared. 3x squared dx. We know how to anti-differentiate that. That is going to be x cubed evaluated at 1 over y and 1. This will give me 1 cubed minus 1 over y cubed. And that is the same as 1 over 1 minus y cubed. And that is the cumulative, g of y. Now, this problem asks me not for the cumulative, but it asked me for the density. So the density of y, that is the derivative. So I'll just take the derivative of this. And I'm going to write 1 over y cubed in a slightly different way. That's equivalent. That'll be y to the minus 3. So now the derivative of the constant's 0. I'll have minus, and then I bring down the minus 3. So I have minus a minus 3 times by y to the negative 2. That's going to be equal to 3 over y squared. And then this is the density, and we'd say for y bigger than 1, because that is the range, right? Y is between 1 and less than infinity, or just y is bigger than 1. So I found the density function, and I found the interval for which it's non-zero. So I can calculate probabilities with this density function. Thank you very much.